Greetings, I'm Dev the Developer.
And I'm Glitch.
Last video, we built a bank account class with a constructor and some properties. Today, we're going to find a problem with that class that we didn't know we had. Then, we're going to fix it using something called encapsulation and access modifiers. So, let's pull up the bank account class we built last time.
On it. And we used it something like this.
Right. Now, I want you to do something for me. Without changing the class at all, give Alice $10,000.
Okay, that's actually really easy. Done. Alice is rich. You're welcome, Alice.
Sure, now give her $1 billion.
I mean, I feel like there should be some kind of check here.
Exactly, and that's the problem. There's nothing stopping anyone from setting balance to any value they want from anywhere in the program. No validation, no rules, the class has no say in it.
Wait, so the class can't protect its own data?
Not right now, and that is what access modifiers are for. An access modifier controls where a piece of code can be used from. Whether that's a property, a method, a field, you can decide who gets to touch it.
Okay, so there are different levels of access.
There are 4. Public means anyone can use it from anywhere. That's what everything in our class is right now. Private means only code inside the same class can see it. Those are the 2 you'll use constantly. There's also protected and internal, but we'll set those aside for now. Protected gets interesting when we talk about inheritance, and internal is more about library design. For today, public and private are the whole conversation.
Okay, so if I make balance private, nobody can mess with it from outside the class.
Give it a try.
There, now nobody can set it to $1 billion from outside.
Go ahead and run it.
Oh, that's who that broke the console.write line.
What does the error say?
It says balance is inaccessible due to its protection level, but I just want to read it. I'm not setting it to anything bad.
Look at your property again. What did you actually change?
I put private in front of O's. I made the whole property private, so both the reading and the writing are locked out.
Right. What did you actually want to lock?
Just the writing part. I want reading to still work, so just the set.
Just the set.
Okay, so how do I do that? Can I put private just on the set?
You can. It looks exactly like you'd expect.
Oh, so public on the property means the get is public, and then private set means only code inside the class can write to it. The 2 sides can have different access levels.
Exactly. Now reading the balance from program.cs still works.
Yep, that's an error now, which is what we wanted, so the class is protecting itself.
It is, but here's the thing. Right now, the balance is stuck at 0. If nobody outside the class can set it, how does the money actually get in or out?
Oh, so the class needs methods for that, like a deposit method.
That's the idea. And inside those methods, we can enforce actual rules. The property setter is still accessible from inside the class, so our methods can use it. But any logic we put in those methods is unavoidable now. There's no way around it from the outside.
Okay, let me write deposit and withdraw.
Go ahead. Good. Now walk me through the withdrawal check.
So first I make sure the amount is actually positive, same as deposit. Then I check if they're trying to take out more than they have. If either of those fail, I print a message and return early. If both pass, I subtract from the balance.
And why does that work? Why can withdrawal touch balance when program CS can't?
Because withdraw is inside the bank account class, and private set means code inside the class can still write to it. So our methods can update the balance, but code outside has to go through those methods.
That's encapsulation. You've wrapped the data inside the class and you've exposed only the operations that make sense. The class controls what happens in its own state. Nothing outside the class can bypass that.
That's actually a really solid pattern, like the class is the only authority over its own data. I mean, you could apply that to basically any system. Anything that should have a single controlling authority over all the data flowing through it. No unauthorized writes. Everything goes through the approved channel. Very clean.
I'm gonna pretend that was about software architecture.
It absolutely was.
Let's wire it up.
There we go, $300 arrived at through legitimate means.
Now, here's a question. You've seen two ways to write a property at this point. The auto property with private set, which is what we just used, and the full property syntax with a private backing field and validation in the getter and setter. Do you remember that one?
Yeah, that's the one where you have a separate private backing field and then the property reads and writes through it. You can put logic in the setter directly.
Right. So with private set on an auto property, the enforcement lives in the methods. The setter is just an assignment. But if you want validation that runs every single time the value changes, even from inside the class, you'd reach for the full property syntax instead.
Wait, so like if I wanted to make sure balance could never go negative even from inside the class.
For instance, if you can't trust your own methods to behave, you put the guard in the property itself.
Okay, so let me write that out. Full property, backing field, setter validation.
Sure. Good. There's one thing that bothered people about this pattern though. What's the relationship between that backing field and balance?
They're the same data, the backing field is just the storage. Balance is the public face of it. The property reads and writes through it.
So you have two names for one thing, and the only reason that backing field exists is to give balance somewhere to store its value.
Yeah, it's kind of just boilerplate. You have to declare it even though the compiler could technically figure out that it needs to exist.
C#14 agreed with you. There's a new keyword called field that does exactly that. Instead of declaring a separate backing field, you write field inside the property, and the compiler generates the storage for you.
Wait, so I can just write field instead of that backing field.
Exactly that.
And I just delete the backing field declaration entirely.
Delete it entirely. The compiler handles it. You get the same behavior, a private backing store that only this property can see, validation in the setter, public get.
So field is kind of like a hidden variable that exists but has no name you can reach from anywhere else.
That's exactly what it is. The compiler generates a private field behind the scenes, and field inside the property is how you refer to it. Nothing else in the class can access it directly.
So it's like the compiler is doing encapsulation on your behalf. The backing store is completely hidden, not just private to the class. It has no identifier anyone outside the property can reach.
That's a good way to put it. The field keyword tells the compiler, I need somewhere to store this value, you pick where, and only let this property touch it.
That's actually fascinating. A storage location that exists but has no identifier anyone else can reach. The compiler allocated memory, associated it with a specific accessor, and stripped every external reference path.
It's a quality of life feature, yes.
Right, yes, that's what I said.
Now, let's put this together in the full class and see what we're working with. Now, when we deposit or withdraw, the setter runs every time. If anything tries to set the balance to a negative value, the property just refuses the assignment. The field does not change.
Wait, so now the validation doesn't live in withdraw anymore.
It can live in both. The method checks that the withdrawal amount is valid before even touching the property. The property checks that whatever gets written is a legal balance. Different levels of the same guarantee.
Okay, so withdraw is saying, is this a valid thing to ask for? And the property is saying, is this a valid state to be in? They're not doing the same job.
Exactly right. The method validates the operation. The property validates the data. both matter.
Okay, so I want to make sure I'm seeing the whole picture here. We started with balance fully public. Anyone could write to it. Then I tried making it fully private and broke reading. Then we did private set, so reading is public but writing is locked to inside the class. And then for validation in the setter itself, we used the field keyword instead of writing a separate backing field.
That's the whole arc. Each step answered a specific problem, and that's usually how access modifiers work in practice. You don't plan it out from the beginning, you feel where the class is too exposed and you close the gap.
That makes it a lot less intimidating than I thought it would be. I was expecting access modifiers to be this whole system I had to memorize up front.
Once you see what the problem is, the solution becomes obvious. That's usually how it goes.
Oh, it's just several simple things stacked on top of each other.
Every time. The gap between a class that trusts the outside world and the one that doesn't is just a few extra words. Go back to any class you've already written, find a property that anyone can set to anything, and ask yourself, what could go wrong if they did? Then decide private set, a method, or a setter with validation. Don't just watch it. Do it.